In this tutorial, I'll show you how to solve a system of equation word problem, either graphically or algebraically. Let's get started. Suppose you're testing two fertilizers on bamboo plants A and B, which are growing under identical conditions. Plant A is 6 inches tall and growing at a rate of 4 inches each day. Plant B is 10 inches tall and is growing at a rate of 2 inches each day. Write a system of linear equations that models this scenario, where D represents the days of growth. So it looks like my first sentence here for plant A is that it has an initial height, right? An initial value is a y-intercept, has an initial value of 6 inches. And its rate of change, right? It says its rate of change here is 4 inches each day. So I'm going to use function notation, right? This is function notation. But they said that my input value is D. So since this is plant A, I'm going to call this equation A, and I'm going to say that its input is D. And it looks like I have an initial value of 6 and a growth of 4 inches per day. Now I'm going to do the same thing for plant B. So I'm actually going to call this function B. And again, its input has to be the letter D. And this one has an initial value of 10 inches, and it's growing at a rate of 2 inches per day. So there's my system. I know it's not a y equals mx plus b sentence, but it still makes sense in the context of this question, and it fulfills the requirement of using the letter D. All right, the next part says, on the set of axes below, graph the systems of equations. All right, well, they're already in slope-intercept form, so all I really need to do is fill out my scale here. So I'm going to copy these here. I'm going to shrink them down just a little bit so I can move them to the side here and refer back to them as I scroll my screen. Okay, so it looks like D is my x-axis, and f of D, right, that's my function there, is where I'm going to put my growth height, right, of how much it grows each day. So it looks like I got 10 and 6, and I go up by 2s and 4s. I got a lot of even numbers here. So I think I'm going to go with 1, 2, 3, right? 1, 2, 3. I think I'm going to go, whoops, sorry. I think I'm going to go by ones here for how many days of growth we have. So we've got 1 day of growth, 2, 3, 4, 5, 6, 7, 8, 9, 10 days of growth. 11, 12, 13, 14, 15 days of growth. Let's see if that will work. And then for my height, since we have starting inches of 10 and 6, I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Now I could certainly put in more labels here, but I don't want to get too crowded. All right, so to color code this for your ease, I'm going to start with red, which has an initial value of 6. And it has a rate of growth, which means it's increasing, right? It's increasing. It's a rate of growth of 4 per day. So 2, 4 every 1 day. 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 All right, that looks pretty good. I'm not sure if this is a good scale down here, because it seems like my graph doesn't go very far, but now I'm going to label it. Okay, that's, not A of X, it's A of D. That X is a bad habit, huh? All right, now blue. Have an initial value of 10. 2, 4, 6, 8, 10. And it looks like I increased 2 inches per day. 2 inches per 1 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 day. I'm liking this already. You know why? I always love when one of my new points overlaps, one of my old points, because that generally means I'm doing something good. So it looks like this one will continue with a pattern like this. Now again, I don't have any arrows on the left-hand side because your plant can't have negative growth. All right, you're not going to have negative growth. So let me put that label back. All right, that looks fantastic. All right, let's take a look at the third part. Name the point of intersection and describe the meaning and context of this question. All right, so let's go look here. Looks like the point of intersection Let me circle it in green for you. Looks like the point of intersection is going to be 2, 10, 12, 14, 214. So it looks like I have the point 214. So I'm definitely going to get a point for writing the coordinates. Now I have to earn my other point by describing the meaning. So remember, this is an ordered pair. And our axes were labeled as days and height, right? So our days and height. So you need to use these words in your description. So after 2 days, both plants will be 14 inches high. Let me go back and just double check it was inches, right? Yes. All right, so that is describing the meaning in context. That means I used the names of my axes labels, right? I used the names of my axes labels. Okay, so that's how you translate a system, graph it, and interpret it. Let's try another method. Mario and Sal bought some pens and pencils. Mario bought 4 pens and 5 pencils for $6.71. And Sal bought 5 pens and 3 pencils for $7.12. So this equation is going to be different. I'm still going to be writing a system, but this one is talking about 2 items being bought. Not one is necessarily being in relation to the other. So I'm not going to have a sentence in this order, because that wouldn't make sense, because then I'd be describing to you how much the rate is changing, right? That doesn't make sense in this story right now. So it looks like I'm going to have a standard form equation. I'm talking about 2 quantities, and the sum of them is equal to something. So it says to write a system of linear equations that models this scenario where x is pencils and y is pens. Oh, fantastic. So we've got Mario, we've got Sal, and it looks like Mario buys 4 pencils and, 5 pens. Ooh, boy, I wrote this in the wrong order. Let me just switch this. Let's say this is going to be pens, and this is going to be pencils. Yeah, I think I copied the problem wrong. All right, we're good. We're good now. So we've still got Mario and Sal. So Mario is 4 pens and 5 pencils, and that's $6.71. And then Sal is 5 pens and 3 pencils for $7.12. Okay, there's my system. And now it says, using your equations, algebraically determine the cost. So that means I need to use, I'm going to just duplicate this. Whoops. So I don't have to write it all over again. I need to use one of my fancy methods. And if you remember correctly, that's going to either be the elimination method or the substitution method. So substitution method would require that one of my letters be all by itself, one of my variables be isolated, which I don't even remotely have. So what I'm going to do is use elimination method, and I'm going to cancel out the y term. I'm going to multiply this by -3, and I'm going to multiply this by 5. It doesn't matter which letter I can't eliminate, and it doesn't matter which one I make negative. So I'm going to need a calculator for part of this problem. So let me see if I can open that up. Okay, so the first part is going to be negative 12x minus 15y, and then this is why I wanted my calculator, 671 times -3. 671 times -3. Oh, I pressed the subtraction sign instead of the negative sign on my keyboard. -2013. Okay, -2013. Now for my red sentence, I'm going to get, 25x plus 15y, and now I need to do 5 times 712. 5 times 712, get 3560. 3560. And I'm going to combine these together, and this makes a 0. So I get 25 minus 12, 25 minus 12, and then 3560, and a negative or minus 2013. All right, now I know you might be thinking, why are you using your calculator to do 25 minus 12? You know why? Because I don't want to make a mistake. So there's no shame in that. So we have 13x equals 1547. And then I'm going to finish this off by dividing by 13. And it looks like I get x is equal to $1.19. And just because I don't even remember what x is equal to, I'm going to scroll up. I think x, I know I had to change it. X is pens, so I'm just going to make note here. Pens cost, oops. Got to do my undo button here. Pens equal $1.19. All right, I'm not totally done yet. I got to figure out how much my pencils cost. So here's what I'm going to do. I'm going to choose either the green sentence or the red sentence, and I'm going to remove the letter X and replace it with $1.19. So I think I'm going to choose the green sentence. So I'm going to write, but instead of the letter X, you know what I'm going to put there, right? This is called the substitution method. I'm going to put $1.19. All right, so 4 times $1.19. 4 times $1.19 is 476. So I've got 476 plus 5y equals 671. Now I'm going to subtract 671 minus 476. And then I get 5y equals $1.95. And then I'm going to divide both sides by 5. Oops. Didn't mean to do that. Now, I could write those steps here on my paper, but I'm just using my calculator real quick to get through this. So it looks like y is equal to 39 cents. And those would be the pencils. Pencils equals 39. Oh, that looks like a 10. Be careful. 39 cents. Yeah, that was kind of messy. Let me fix that. Awesome. All right. And that is how you solve a system algebraically. Here's another type of question you might see on a Regents exam. Why don't you give it a try? All right, pause the video and give this a try. All right, I'm going to solve this algebraically like it says, but I'm going to show you a substitution method instead of elimination, just to give you some more exposure. So here's the system you should have translated. Dimes and quarters is 90. 10 cents per dime, 25 cents per quarter. It's a total of $17.55. So instead of multiplying the entire first term by like negative 0.10 or multiplying by negative 0.25, I decided to rearrange it to isolate one variable. I happened to choose D, doesn't matter, and then I chose to substitute this expression, 90 minus Q, into the variable D. And I solved this problem using that substitution method. So if you used elimination, you still should have gotten the same answers that I did. All right. And that's how you solve systems of equation word problems, either graphically or algebraically.